Hello, future engineers. There is another video in differential calculus or in solid geometry, and I find it a beautiful problem for you to experience. Though we apply, I, up, I presented two solutions. I'll present two solutions here. One is by the prismoidal formula and the other one by integration. So here is the problem. A barrel has the shape of an ellipsoid of revolution with equal pieces but off the ends. If the barrel is 100 centimeter long with circular ends of radius 20 centimeters and a midsection of radius 40 centimeters, find the volume in liters of the barrel with or without integration. So I'll solve this without integration first, and let's express the dimensions in meters so that the volume will be in cubic meter, and we just multiply 1000 to convert the volume to liters. So here is the figure. At the ends, we have radius zero point 0.2 meter, 20 centimeter. That's zero point 0.2 meter. At the midsection, the radius is 40 cm, so that's zero point 0.4 meter, and that is also the semi minor axis B zero point 0.4. This is B for an ellipse. So I extended it, and the distance from one left end to the center midsection is zero point 0.5 because the length or the distance between end sections is 1 meter as 100 centimeters as stated here. And the distance from the center of ellipse to the vertex, rightmost vertex, is denoted by A. So this is zero point 0.5, and A is expected to be slightly greater than zero point 0.5 meter. So without integration, volume by prismoidal formula is L over 6 times quantity area of end section 1 plus 4 times area of the midsection plus area of the other end section 2. Take note that the solid is symmetric with respect to both axes. So the volume should be, for area 1 is equal to area 2, which is area of a circle pi point 2 square. While the area of the midsection is area of a circle also radius 0.4. So L is 1 meter, as I said, zero point 0.5, then another zero point 0.5, so that's 1 meter. So substitute volume equals 1 over 6 quantity pi times zero point 0.2 square plus 4 times pi 0.4 square plus pi times zero point 0.2 square. So in terms of pi, using your calculator there, the volume equals 3 pi over 25 cubic meter. In decimal, that's 0.3770 cubic meter, and in liters times 1,377 liters. So that's the volume without integration. Now, if we solve this by integration, let's have a disk shown. The differential volume of this disk is pi y squared. The radius is y, and it is an ellipse of revolution, so that's why the radius, the section is circular. That's why it's a disk. The thickness is dx, and our limits will be from 0 to zero point 0.5, and we multiply the entire volume by 2. So volume equals, the differential volume is pi y square, area of circle, thickness dx. Then we multiply the volume by 2. So volume equals 2 times integral from 0 to zero point 0.5 pi y square dx. Now how to solve for y? The standard equation of an ellipse with center at the origin is x squared over semi major axis a squared plus y squared over semi minor axis, which is zero point 0.4 here. 0 point 0.4 square equals 1. So 2 pi integral 0 to 0 point 0.5 y square dx, and x squared over a squared plus y squared over b squared equals 1. That's the standard equation of an ellipse with center at the origin. So at this point here, the coordinates would be x is zero point 0.5 and y is zero point 0.2. And take note that b is zero point 0.4. So 0 point 0.5 square over a square plus 0.2 square over 0 point 0.4 square equals 1. Simplifying, that's 0 point 0.5 square over a square equals 3/4. So a square therefore is 0 point 0.5 square over 3/4, and that is 1/3. Substitute into this equation so that we'll have an expression for y square for us to evaluate the integral. So x squared over 1/3 plus y squared over 0 point 0.4 square equals 1. So that means y squared is 0 point 0.4 square times quantity 1 minus x squared over 1/3. And if we simplify this, 0 point 0.4 square is 4 over 25. Then we can simplify the terms inside the parentheses as 1 minus 3x squared. So 4 over 25 times 1 minus 3x squared. Substitute in this formula here, volume equals 2 pi integral from 0 to zero point 0.5 of 4 over 25 1 minus 3x squared dx. So we can easily evaluate this by power formula. So volume equals 8 pi over 25 times quantity x minus x cubed from 0 to zero point 0.5. So volume equals 8 pi over 25 quantity 0.5 minus 0.5 cube. So we can now solve volume, which is equal to this. So volume equals 3 pi over 25.3770 cubic meter, 377 liters. So it's the same. Actually, after setting up the integral from here, you can use your high-tech calculator to evaluate this integral. And it is an easy task to set up the integral because the differential elements will just be a disc like this, or a disc with holes, or a cylindrical shell. So that's it for this video.